And forest refers to multiple trees. Sorry. See, decision trees only disadvantage is overfitting. Overfitting means on training data, you get a very good accuracy or very high accuracy. But when you repeatedly test the model with the same data or subset of the data, the accuracy drastically falls to a very lower level. Or in case of regression, the trained model has a low RMSE, but if you test it again with sample of data, the RMSE increases drastically. That we call it as overfitting. Okay, so decision trees are by default open to overfitting. To overcome this overfitting problem within the decision tree, the multi-tree models or ensemble methods are developed, within which bagging is a very popular model. Random forest particularly overcomes the overfitting problem. Overcomes the overfitting problem that is there in decision tree, which is a single tree model. And decision tree is a single tree model. Random forest is a multiple tree model where you will multiple decision trees. So random forest is a very powerful algorithm which is very widely used in data science, and it has one of the highest accuracies. It will give you highest accuracies and low RMSE. Now the algorithm works like this. Step 1, specify the number of trees to build. You have to first specify the number of trees to be built. N underscore estimators is equal to 1000. So you are specifying that you are building 1000 decision trees. You are asking the algorithm to build 1000 decision trees. 1000 decision trees, like how we have built a single tree model, same process is followed and 1000 decision trees will be built. 2 is the most important part. It starts to create 1000 samples of data from original data, and each data sample will be randomly sampled 65% of observations, 65% of the observations are rows, and square root of number of variables. Square root of number of variables. So each data sample will have randomly selected 65% of observations and also randomly set what you call the square root of number of observations. Guys, you are not able to hear my voice? Is my voice clear? Participants, can you confirm, is my voice clear? Yeah. Okay. So the first step in random forest is specify the number of trees to be built. How many trees you have to build, that needs to be specified. And then the sampling process will be starting. It has to create 1000 samples of data from original data, and each data sample will be randomly sampled 65% of observations and square root of number of variables. And it also uses data with replacement methodology wherein whenever new sample is created, it takes into consideration complete data universe. So this means multiple observations and variables appear in multiple samples, thereby in multiple trees. So one of the unique thing you need to understand in random forest is the sampling methodology. The success of your algorithm will depend on whether your sampling methodology is executed or not. If there is any problem in step 2, that means the algorithm is not in a position to create 1,000 samples, then the algorithm will fail. It will not go into model building at all. It will first has to complete the sample process of 1,000 samples. Once these 1,000 samples of data have been created, then only it will go to the next step of building the decision trees for sample. One sample, one decision tree, that is built at the step 3. In step 2, each data sample will be 65% of the data randomly selected and square root of number of variables randomly selected. So every sample will be different in terms of the rows and the variables, and also will have similar observations because data with replacement. So the observations which were there in the previous samples will also repeat in the other samples also. So that is the process of data with replacement. So observations and variables appear in multiple samples, thereby in multiple trees. So for your understanding, random forest sampling with replacement now you can see the data here. The training data set is here. So if you see the training data set, there are 4 variables and 1 dependent variable. In the first sample, if you see here, you have observation variables x1, x3, and x4, and observation A1, C1, D1, A2, C2, D2, A5, C5, D5, randomly selected rows. This is your sample 1. And in sample 2, you have x2, x3, and x4. So variable x4, x3, and x4 are repeating. And then you can see in case of observations, C1, D1 is repeating, and only C1, D1 is repeating in case of observations. The rest of are new observations. Similarly, in sample X, you have X1, X2, and then you have A2, B2 repeating, and then A3, B3 repeating, and A5, B5 repeating. So this is how the data will be sampled. This is called bootstrap sampling. And then once the sampling is created, for every sample, one decision tree will be built. So all of you got this? Step 3. Once 1,000 samples are created, one decision tree or one sample is built. So exactly the same type of decision tree, exactly the same type as a single decision tree, as a decision tree model. Decision tree is built. Okay. And step 4, predictions for all the trees will be done and output aggregated. Step 5, for classification problems, for classification models, majority voting is used, and for regression models, average method is used for final prediction for observations. So the final prediction will be, since the observation will appear in multiple trees and multiple trees also predict, and when you have multiple predictions, the output is aggregated and majority is voting is used in classification, and average method is used in regression models. So this is the process of random forest algorithm. That is the process. Why with replacement means the objective is wisdom of crowds. There is a concept called wisdom of crowds. A single tree might make a mistake, but multiple trees, the chances or probability of making a mistake will be lower. It's like committee-based decision making, or like we have in India, parliamentary democracy. If you allow one dictator to take a decision, he will take a decision in a bad manner. But if you are doing a decision based on a group or a community or a set of people, the chances of the decision being wrong or the chances of the decision being negative will be less. It's like wisdom of crowds. That is what the basic logic behind this algorithm. So the observations appear in multiple trees, so the chances of their correct prediction will also be high than a single tree. Is that clear? So this we call it as wisdom of crowds, multiple people making decisions rather than one single person making the decision. Any other doubts, participants? And tree building is parallel. Parallel building of trees is one of the unique things here. Parallel building of decision trees as each sample is independent. As each sample is independent, you can parallelly build multiple trees. So all of you got this? Can I proceed, participants? Yeah, the trained data or the trained data is what it will create multiple data samples. If you can give combined data also, it will create multiple samples. Trained data is what we have to do multiple samples. Trained